All right, good afternoon, you guys. Today we are diving even deeper into quantitative data, ways to visualize it. So today we're taking on the histogram. So here first, I just wanted to remind you of where we've been. You can use a dot plot or a stem plot to display quantitative data. So quantitative data means we're looking at something that's numerical, that it makes sense to analyze. My go-to example here is height. That is a good example of quantitative data. Okay, both the dot plot and the stem plot are able to show every individual data value, so that's the appeal of that style of graph. But for large data sets, that can make it really tricky to see the overall pattern in the graph. So we're making way for our new style, which is the histogram. So by ignoring individual data in favor of groups, we can gain a better understanding of patterns and relationships in data. Histograms show each interval as a bar, and the height of the bars show the frequencies. Right? It's a fancy word for count. And relative frequencies, which would be percent or proportion. Right? We could write it as a decimal or fraction as well. We're just showing how it relates to the overall group. So our heights can be frequencies or relative frequencies. Here's an example. And I'm really trying to show you a side-by-side comparison of a dot plot and now a histogram. So the figures show a dot plot and histogram of the duration in minutes of 220 eruptions of the Old Faithful geyser. Notice how the histogram groups nearby values together. So here, the dot plot, what's appealing is that I can see all of those individual data points, right? But that's 220. I don't want to plot 220 values. So I'd rather group them together in classes and look at it like this as a histogram. So histograms are appealing for large sets of data. All right, how do we make it? So here we need to choose equal class widths that span the data. 5 is a good minimum. I'm going to be a little bit more precise. I'm going to say 5 to 8 classes is a good rule of thumb. Okay, 5 to 8 is usually a good starting point. Okay, we always start with a table, right, that either shows frequency or relative frequency. Okay, we want to draw and label our axes. So our quantitative variable is under the horizontal axis. So here it was duration. And then the vertical axis, the y-axis, is the frequency. Let me slide that down for a second. The frequency or the relative frequency. The graph will actually look exactly the same, whether you're looking at frequency or relative frequency, if you have it using the same scale. All right, so then in 4, scale the axes. So place equally spaced tick marks at the small value in each interval along the horizontal axis. On the vertical axis, we start at 0, just like we do for bar graphs, right? We always start at 0. And then we make equal tick marks until we get to the tippy top. Okay, the scaling part is probably the trickiest part for the x-axis. Okay, we draw our bars. We go as high as our largest frequency or relative frequency. And I just wanted to tuck in here that an interval that has no data values will appear as a bar with a height of 0, or we think of that as a gap. Okay, so I don't have any gaps in my histogram up here, but I have a few gaps in my dot plot when I was looking at individual pieces of data. Okay, I want to give you a little beware. So beware of picking too few classes or too many. So if I pick too many, this is what could happen. So if I pick too many classes, it's not going to tell me a whole lot because I'm going to have a lot of gaps, a lot of really short bars like this. Right? That really doesn't tell me any story, right? That doesn't really tell me what the data is trying to show. Or I could pick too few. So all of my data could clump together in just a few really tall bars like this. And that really doesn't tell me much either. right? So over here, we think of this as kind of a pancake effect. And over here, this is more of a skyscraper effect. So it's what I'm saying as, well, beware, you don't want to pick too many classes. Again, doesn't really tell you much. I don't see any data clustering in any region of my graph, or I could have too many, right? It still doesn't tell me that much either. So I'm saying as a good rule of thumb, we want somewhere between 5 and 8. So with the amount of data that we're going to be working with, we're going to say 5 to 8. All right, so what are we actually doing when we make a histogram? So let me slide this up a little bit more. So here what I'm looking at is the percent of foreign-born residents, so people that were born in a foreign country. So here we see what the dot plot would look like, and the dot plot is showing me all of the individual data points. And then what I'm doing is I'm grouping them into classes. So here we're seeing from 0 to just under 5% would go in here, and 5 to just under 10 would go in here. Here's 10 to just under 15 and so forth. So then we're taking all of those individual pieces of data that fall in those regions, and we're just picturing them as a certain frequency. So we're just stacking them up as these are all the data points that fall within these two cutoffs, in between 0 to just under 5, from 5 to just under 10, etc. And then instead of showing individual little dots, we make them pretty bars instead. So I can see here that my distribution would look unimodal. Here, right, unimodal, I have a cluster of data right over in this region, and it's tapering off to the right. So this would be skewed to the right. Whichever direction my tail leads me in, that's the direction in which it is skewed. So we're just taking all those individual data points, putting them into classes, and then making a histogram. All right, let's make one. All right, so flip it over on the back side. We are going to make a histogram. So what I'm giving you already is I'm giving you a frequency table. So let me write that out right here. This is a frequency table. And the data in the table show the number of pedestrians that are killed in a single year in a large city by age. So pedestrians, that means just a person who's near a road or some sort of urban area. Let me define that for you. So here, a person near a road or other urban area. That is a pedestrian. All right, we want to build a histogram. What's really nice is that we're already given our classes, and then we want to talk about the shape, the center, and the spread. So here I'm going to write shape. And then here center, as well as the spread. Okay, so I'm just getting myself organized. So now I want to think of my x-axis. So my x-axis, I'm looking at age. So what I do when I transfer my numbers down here is I use all the starting points. So 0, and then here's 10, and then 20, and you guys get the pattern. Right? They have to be stable widths, consistent widths. Okay, and this is ages. So there's my x-axis. And I can see that right here, this is anyone from 0 to 9. This will be anyone from 10 to 19. This will be anyone 20 to 29, for example. Okay, my y-axis, I'm given it as frequency, but it could just be relative frequency as well, right? There's another option. So since I see that my largest frequency is 84, then I want to scale it by tens. I always want to use the space provided, and I always want to start at 0. So I'm scaling it by tens as well. Okay, and I want to point out that these are frequencies or counts. Right? Frequency is a fancy way of saying count. Okay, I'm going to slap on a pretty title. So we're looking at pedestrians killed in a large city. So sorry, it's a little bleak example for today. So pedestrians killed in a large city, grouped by age. Okay, so I have my frame nice and built. So now I need to put in my bars. So from 0 to 9, right here, that's a frequency of 84. So I'm just going to draw that in, about right here. Okay, if you have a straight edge, you can make it even prettier with a ruler. And then I'm just going to shade it in, just like so. Okay, my next one, 10 to 19, is 28. So right about here. 20 to 29 is 9. So right about like that. 30 to 39 is 24. So right in here. 40 to 49 is 19. So right about there. 50 to 59 is 43. So right in here. 60 to 69 is 63, so right here. 70 to 79 is 58, so right in here. And then 80 to 89 is 38, so right about there. All right, so check to make sure that we match, and then we want to talk about it. We want to talk about its shape. So we want to talk about, is it symmetric? Do we see any skewedness? Do we see any modes, any outliers? Where is the center? Where is the rough central piece of data going to fall? What's the spread? What's the small to large values? So for shape, what I'm seeing is two clusters of data. I'm seeing a cluster over here at this young age, and I'm seeing a cluster over here in the 60s and 70s, right in here. So two concentrations of data. So I would call that bimodal. So two concentrations of data. So these two locations. So again, they don't have to be the same height. We're just looking at where we see a concentration of data. And that makes sense. If we're looking at pedestrians, so we're near a road, it makes sense that we do have some young children, right? It's why we train you guys at an early age to look both ways, right? Be really cautious when there's cars around. Okay, and then up here, we're seeing some of our older folk as well. Okay, so these are the two age groups where we see large amounts that are killed in this particular large city. Okay, I really don't see any other shape. If I had taken this part out like that, we could argue that there might be a skew to the left. But we have that big bar right here with a large height. We have a lot of frequency, 84 pieces of data that are in 0 to 9 years of age. All right, the center. So the center, I'm trying to picture where would be the central piece of data? Where would be the middle piece of data if I had it all arranged from low to high? So here, what I'm trying to do, because I don't have the raw data, so I'm trying to visualize where it would fall. So right here, I see that this is 84. And over here, this one is 38, this is 58. So it's roughly about the same. So I'm just going to kind of block out equivalent portions and move my way in. Then over here, I have a 28, a 9, a 24. That kind of balances out with right here. So I'm kind of blocking my way here, and I'm moving towards the middle. So I put it maybe somewhere in the 50s. So maybe right about there would be my approximate center, somewhere in the 50s. I'm going to remind you of this many times. Let's say that I wrote it as 52, and you wrote it as 56. We're in the same ballpark. We're very close. I don't have the raw data, so I'm making an estimation. My estimation is that the center would be somewhere in the 50s. So if you're saying something in that ballpark, I'm good with that. Okay, the spread, again, I don't have the raw data, but I'm just looking at the bookends. So my span is from 0 to 89. All right, so that's how I would describe the shape and the center as well as the spread. Okay, we have one more example. All right, so example 2. Example 2, we're given this table that shows the average elevation of the 50 United States, each to the nearest 100 feet. Design a histogram to display the information with 7 classes. So we're told make it 7 classes. Set up your classes appropriately. I want to remind you that I'm always going to say that a good rule of thumb is anywhere from 5 to 8. And we're using 7 because I said use 7 right here. And then we want to describe it once we've built it. So what we do is our starting point. I've shown you how to sort in your calculator. That would be super helpful. So you might want to take the time to plug in these 50 pieces of data and sort them in ascending order, increasing order, low to high. And then you can easily see what your low and high values are. So your spread, your low value is 100, and your high value is 6,800. Low to high. Lowest elevation, highest elevation. So then I want this to fit into 7 classes. Let me just remind you, 7 classes. So when I look at the difference between these numbers, so if I took 6,800 and subtracted 100, I would have 6,700. Well, that number is not cleanly divisible by 7. And when I look at these numbers, I can see an easy way to have nice increments to work with. So I'm going to come up with my adjusted spread. So if I move these markers a little bit, so if I move this one to the left, this one to the right a little bit, I can find something that is cleanly divisible by 7. In fact, I can see that if I make this 0 and this 7,000, that's going to give me nice clean numbers to work with. So I'm going to adjust it to 0 to 7,000. So when I take 7,000 minus 0, right, I get 7,000. And if I split it 7 ways, then my class width will be 1,000. Let me write that down. So the class width will be 1,000. So now I need to make my classes. So what I do is I start with 0. My class width is 1,000. So I'm going to write all of the starting points first. So I'm going to say 1,000 next, and then 2,000, 3,000, 4,000, 5,000, 6,000, and then I'm not going to have an 8th class, but if I did, the starting point would be 7,000. I usually write that below it, right there. So then I need to put on the caps for each class. So this one would be 0 to just under 1,000. So I'm using this notation, 0 to just under, less than this next starting point right here. So now I know what to do for all of them. So this one is 1,000 to just under 2,000, 2,000 to just under 3,000, 3,000 to just under 4,000, 4,000 to just under 5,000, 5,000 to just under 6,000, and 6,000 to just under 7,000. Okay, so I've built my 7 classes. I have 7 classes. And I just want to double check, does every piece of data have a place to go? So I can see that my low value is 100. Great, that would have gone right here. My largest value is 6,800. Great, I have room for it right here. So I just want to make sure that every piece of data will have a place to go. So now I need to tally up the frequencies. And again, this is where it would be super helpful if you took the time to type all of your data into the list 1 and sort it in ascending order. Okay, I'm just going to skip ahead and tell you what the frequencies are. So I should have 22 states that are in that first class, 0 to just under 1,000. Okay, and then 14 would be next, then 5, 2, 1, 3, and 3. Okay, if I added these up, this would be all 50 states. So now we have our little chart to base it on, and we need to organize that as a histogram. So my x-axis is the elevations. So I'm going to go 0, go by 1,000s, okay, mark it. Context is crucial. So here we're looking at elevation. Okay, the y-axis is our count, our frequency, but we could also do it as relative frequency too. But here we're just doing it as frequency. That's what we were given. We were given the counts. So my highest one is 22. So I'm going to go ahead and scale it by 2s. Again, I have to start at 0. Always start at 0. I like you to use the space that I'm providing, which is why I'm scaling it by 2, so I can go all the way to the top. And this is frequency. Okay, I'm going to slap on my pretty title. Let me slide that over for a sec. So frequency. My title is we're looking at U.S. elevation. And we're rounding it to the nearest 100 feet. Okay, so now I'm going to put in my bars. One other thing I just want to emphasize is that with a bar graph, we always have spaces between our bars. We do not do that for histograms. We keep them smushed right next to each other. So my first one is 22, so right here. Again, if you have a straight edge, that would be ideal. Just trying to go fast. So there's my first one, and then 14. 5, 2, 1, 3, and one more 3. Okay, and then I want to think of how to describe it as well. I want to describe the shape. Where is the approximate center? And center for the time being, we're looking for that central piece of data. So if I had my data organized from low to high, where would I be right smack in the middle? And then spread. Okay, so what really stands out to me in terms of the shape is that I see one place where there's a concentration of data, right? Because I have 22 states that have these low elevations between 0 to just under 1,000. So I would say unimodal. Okay, I would also throw in that there's a nice little skew to the right. So I see a lot of states with low elevations, then it tapers off towards the right. So the direction that the tail leads you, that is the direction that it is skewed in. So skewed to the right. Where would my approximate center fall? So here, if I have 50 pieces of data, here's 22 of them, it's pretty clear it's going to fall somewhere in here. So if I was making an estimation, I'd say, well, maybe about 1,500, 1,500. And I'm going to remind you that if you say something that's close to that, that's okay. We do not have to match. We just have to be in the same ballpark. Okay, and then the spread is always the actual spread. It's not your adjusted spread. It's always tied to the data. So the low value was 100. and the high value was 6,800. All right, we will circle back and practice this more when I see you guys in class. This is a good first layer of what is a histogram, what's its purpose, and then how do we construct a good one. Have a good rest of your day.